action?
So for our project, we are doing it on the events of El Nino and La Nina. And the project is by Matt Dorgan, Luke Stinson, Jackie Jarrett, and Matt McCord. La Nina is a climate pattern that describes the cooling of surface ocean waters along the tropical west coast of South America. La Nina is considered to be the counterpart of El Nino, which is characterized by unusually warm ocean temperatures in the equatorial region of the Pacific Ocean. Together, La Nina and El Nino are the cold and warm. La Nina events sometimes follow El Nino events, which occur at irregular intervals of about 2 to 7 years. The local effects on weather caused by La Nina are generally the opposite of those associated with El Nino. For this reason, La Nina is also called anti-El Nino and El Viejo. La Nina is caused by a buildup of cooler than normal waters in the tropical Pacific, the area of the Pacific Ocean between the Tropic of Cancer and the Tropic of Capricorn. Unusually strong eastward moving trade winds and ocean currents bring this cold water to the surface. This process is known as upwelling. The effects of both El Nino and La Nina affect patterns of rainfall, atmospheric pressure, and global atmospheric circulation. Atmospheric circulation is the large-scale movement of air that, together with ocean currents, distributes thermal energy on the surface of the earth. These changes are the main sources of variability in climate for many areas worldwide. La Nina is characterized by lower than normal air pressure over the western Pacific. These low pressure zones contribute to increased rainfall. Rainfall associated with the summer monsoon in Southeast Asia tends to be greater than normal, especially in Northwest India.
Also known as Southern Oscillation, irregularly occurring complex series of climatic changes affecting the equatorial Pacific region and beyond every few years. El Nino is characterized by the appearance of unusually warm water, nutrient-poor water off northern Peru and Ecuador, and it's typically in late December. It disrupts the Walker's cell circulation, which is a model of airflow in the low-trip atmosphere. El Nino occurs every 2 to 10 years, highly irregular, and it usually lasts around 2 to 12 months. Thermocline reaches deeper on the western side of the ocean. Upwelling occurs deeper on the western side of the ocean, and it creates weaker trade winds, forces warm pools to migrate eastward, and creates a drought.
So the trade winds for El Nino go down. Across the board, the trade winds get weaker over. On the eastern side, the warm pool goes down, as well as the thermocline. Also diminishes on this side. In the western Pacific, it also deepens from El Nino, and pressure on the eastern side also weakens. So for El Nino, the pressure weakens, upwelling and lower biological on the eastern side goes down. So the pressure and upwelling. All right, kill it.
No, you were good. You
No,
were right.
So for La Nina, on the eastern Pacific side, we have an increased thermocline, as well as trade winds coming towards the east. The trade winds are also stronger. And on the western side, the trade winds get weaker. And on the western side, there is more of a flood, which is caused by El Nino. Also, on the eastern side, we have higher upwelling, as well as a higher biological productivity for the thermocline on the western side. It's also increased by La Nina.